Hello everyone. In this video, I'm going to explain you how to automate AWS infrastructure for secure microservice deployment. I have designed and implemented a fully automated AWS infrastructure to securely deploy our microservices using continuous integration and continuous deployment. This solution enables a seamless end-to-end automated purpose for deploying, managing, and scaling microservices efficiently across different environments like deployment, testing, production, while maintaining security, reliability, and cost effectiveness. So when come to the end-to-end automation using a single script, so this infrastructure is built using infrastructure as a code principle, primarily leveraging Terraform. With a single script we can provision the entire infrastructures in AWS, including EC2 instances, RDS database, security groups, and pipelines, deploy the microservice seamlessly without manual intervention, manage scaling policy to ensure performance optimization based on the load, and implement rollback mechanism in case of any deployment failures, destroy resources when no longer needed to optimize the cost. So these automation eliminates manual configuration and ensures consistency across all environment. By using parameterized configuration, we can deploy the same microservices in different AWS environment by simplifying changing the AWS account credential and environment variables. So, automated rollback mechanism for this reliability to ensure minimal downtime and a recovery from failures. The infrastructure includes automated rollback mechanisms such as version control in Jenkins, Terraform state management, automated backup and resource for the RDS. These allow for rapid recovery without manual intervention, making the system highly reliable and resilient. So these automated AWS infrastructure provide a seamless, secure, and a scalable environment for deploying microservices by leveraging Terraform for infrastructure automation and Jenkins for CI/CD. It ensures rapid deployment, minimal downtime, and a cost efficiency. The ability to deploy across development, test, and production environment using single script enhance reliability, while built-in rollback mechanism ensure resilience. So this setup enables organizations to achieve continuous delivery with confidence, optimizing both performance and securities. So here I have a Terraform script for creating the yeah. So this script is used to create an AWS infrastructure that includes an EC2 instance for running a Jenkins servers and hosting a microservices, an RDS MySQL database for storing applications and data, a security group to define network access rule for the EC2 instance and the RDS database. Um, so let's go and understand the script. So here I have mentioned the provider is AWS. So here you can specify anything that you are using AWS. You need to specify AWS, or you have Azure, you can use those things. So this block tells Terraform to use AWS as the cloud provider, and the region is set to EU North 1, that is Stockholm or Sweden, where all resources will be created. In this U1 and U North 1, I have creating all these resources. Uh, with what there is a region you are comfortable, you can go with that region. Here I'm using EU North 1. And the next thing we have is a security groups. So the resource AWS security groups GTS API. A security groups is like a firewall that controls the inbound, that is ingress, and outbound egress network traffic. So these security group will be used by the both EC2 and the RDS. So this is the description I have given, and the name I have given is API. So the next thing, ingress from port 3006 to port 3066 protocol TCP and CIDR block 0.0.0. So the ingress means what the traffic coming incoming traffic, that is called ingress. So allow incoming MySQL traffic on a port 3006 from anywhere. So the next we have is a port number 4703. So allow incoming application traffic on port 4703 which is used by our microservices. So the next port number I have given is 8008. So these allow incoming traffic on port 800 which is commonly used for web applications or APIs. So the next we have given a 0. So this means these rule allow all traffic from any IP, making the instance vulnerable. You should restrict these to only required port and specify IP ranges. And next thing I have given is 22. So allow SSH access only from within the security group itself. This means no external SSH access is allowed. For the SSH purpose secure shell, we are using port number 22. So egress, outgoing means the traffic going from our system. So for that I have given the 0. So allow all outbound traffic to the internet, enable the instance to make API calls, download packages or etc. So here the actual thing we have. In this Terraform script have creating the RDS instance. So the name AWS DB, GTS Service Platform DB. So the identifier is GTS Service Platform DB I have given. So the engine I have using MySQL creates an RDS MySQL database named GTS Service Platform DB engine MySQL, and the instance class dbt4g.micro. It's the smallest instance types, ARM based. So the next thing we have given a DB name, that is GTS Service Platform DB, and the username I have provided and the password also I have provided. And this next thing we have is a storage. The allocated storage is 20 and the maximum allocated storage is 100. So starts with the 20 GB, can expand up to 100 GB, and the security group have given AWS security group GTS API ID. So this security group have mentioned there. GTS API will mention, have mentioned here. So and the multiple availability zone false because only deployed in one availability zone, and the public accessible is true, can access over the internet, and the storage type I have given a GP3, and the backup retention period I have did not take the backup retention here, so I have mentioned 0. And at the last I have skipped the final shot snapshot, so that's why I have given the true thing. So this is how to create the RDS instance. So the next thing we have is a EC2 instance for creating. So here I'm creating a EC2 instance running in a Ubuntu, my Ubuntu instance, and I'm provide the Amazon Machine Image ID, and instance type I have given a 3 T3.medium, and I have given a key name, that is GTS, and in this also I have mentioned the security group GTS API, and the tag I have given. By this tag only it will create it. And here also I have given the user data section in the Terraform is used to provide and initialize the script that runs automatically when an EC2 instance is launched. So this script is written in a bash and it is executed as the root user. So first thing have given sudo apt get update -y. So runs to update the package list for the Ubuntu. These ensure that the latest version of the software package can be installed. So the next command I have given is to install the OpenJDK 17. So which is needed to run Java based application like our microservices. And the next command to install a Maven. Install Maven, a tool used to build a managed Java application required in your microservices is built using a Maven application. And next, I am adding a Jenkins repository key. So this command. So it's download the official Jenkins signing key and saves it in a user shared keys. Um yeah. In this, it will share. So these key ensures that the Jenkins package are installed from a trusted source. So the next thing, um, we're adding the Jenkins repository. So this command echo deb. So add the Jenkins package repository to the system. This tells Ubuntu where to find the latest Jenkins packages. So again, I'm updating the things. Run another apt get update to refresh the package list including the newly added Jenkins repository. And now I'm installing the Jenkins, which will be used for CI/CD automation and allow you to build, test, and deploy your microservices automatically. So the next we have installing the Docker, which is needed to run a containerized application. These allow Jenkins to build and deploy a microservices Docker container. And we are adding Jenkins to the Docker group. So adds the Jenkins user to the Docker group, allow Jenkins to run Docker commands. Without this, Jenkins would not have permission to execute Docker build or Docker run. And we are restarting the Jenkins, so it's recognize the new group permissions, ensure that Jenkins can start running builds immediately. So we have a output. So instance IP value AWS instance my Ubuntu instance public IP. So it displays the EC2 instance public IP after deployment. You can use this IP to SSH into the instance or a access services. And also we have a RDS endpoint, so it will display the RDS database endpoint which is needed to connect our applications to the database. So this is the Terraform script for creating the EC2 instance and the RDS database. So I'll explain you the another pipeline script that is used in a Jenkins. I'll explain here what are the content I have written in the script. So here have using pipeline agent any environment or what are the variables I have defined here is Docker Hub credential. So this pulls the Docker Hub credential and stored in a Jenkins. The credential Docker Hub reference the Jenkins credential manager where the login details for the Docker Hub are stored securely. So you can access the user and a password without hard coding them. So the next thing I have mentioned is AWS region UU North 1. So these specify the AWS region where your infrastructure like EC2 or RDS will be located. In this case, the region is set to UU North 1. The next I have mentioned the environment is Docker username. Your Docker user hub, it's used to tag the Docker image correctly and ensure it's get uploaded to the correct repository in the Docker hub. And the next I have given is the image name. What the image name it should be created in a Docker hub. The name for the Docker image being built, which is GTS time zone services. These name will help identify the image in the Docker hub. And also I have given the container name, the name that will be given to the Docker container once it is created. This helps identity the container which it is running. Here it is set to GTS time zone container. And the next we have is a port number. The port number on which the applications will be exposed inside the Docker container it's set to 4703, which is the port on which your microservices run internally. So the next we have some stages. We have some stages. So let's go and explore things. So each stage represents a specific steps in the CI/CD pipeline. So here is the detailed. So the first thing, so stage one, it's a cloning the repository step, get credential, get URL, and we mention the branch also. Yeah, we have mentioned the branch also. So this stage checks out the latest version of the code from the GitHub repository. So get credential ID. So it uses the Jenkins stored credential which provides secure access to the GitHub repository. You configure the credential beforehand in a Jenkins for the security. URL to the GitHub repository from where the code will be cloned. The branch to check out, in this case main. These ensure that the latest changes from the main branch are used for building the services. So this is the first stage. We have cloned the repository from the GitHub. So the second stage we have mentioned is build with the Maven. So this stage compiles and package the Java project using the Maven and the shmvn clean package. These shell command run Maven clean and package goal. Clean remove any previous compiled artifacts from the target directory, and the package compiles the source code, run test and package the application into a jar file located in the target directory. So these jar file will be used to build a Docker image in the next stage. So the next stage we have is a build Docker images. So these stage build a Docker image for your application from the source code. Docker build, this command builds a Docker image from the current directory. The -t option tags the image with the name and a version. $docker username, $image name, latest. So these tags the image with your Docker Hub username and the image name from the environment variable. So these result in an image name. So the Docker file, which should use the root and your repository, contains instruction for building the image such as setting up the Java runtime, copy the jar file, and setting the entry point. So this is the stage 3. So and next we have is a stage 4, that is push to Docker Hub. So this stage pushes the Docker image that was just built to the Docker Hub so it can be accessed from anywhere. With credential, this securely loads Docker Hub credential into the environment variables, that's a Docker user and a Docker password. Docker login logs into Docker Hub using the user and a password. The password is passed by standard input to avoid storing in the pipeline logs. And Docker push, so this command uploads the tagged image, Docker username, image name latest to Docker Hub, make it available for the deployment later. So in the next stage we have is a to run a container. So this stage run the Docker container from the image pushed to the Docker Hub. So the command run, the Docker run command runs a new container from the specified image. -d runs the container in a detached mode, meaning it's running in the background. -p $port $port maps the container internal port to the 4703 to same port on the host machine, making it accessible externally. Hyphen names a dollar container name. It names this container as a GTS time zone container, and a Docker username and an image line later specify the tag image to run. So the overall script, what did is it's clone a repository, pull the latest code from the GitHub, compile and package the Java code into the jar file, and create a Docker image from the jar file, and upload the Docker image to the Docker Hub, and deploy the Docker container locally, exposing it on a 4703. So these Jenkins pipeline automates the build, push and run purpose for your microservices application. It ensures the application is always built from the latest code, containerize it, push to the Docker hub and run locally, ready for deployment in a production or other environment. So the uses of environment variable helps keep things modular and are reusable across multiple environments. So this is the Jenkins pipeline. I'll show you at the time of implementation. So I have explained the Terraform script, pipeline script, and have to explain you another one, that is a Docker file. Have mentioned what the thing have mentioned here. So this is the Docker file I have. So yes, so this Docker file is used to create a Docker image for running a Java application GTS time zone services. So it starts with the open JDK 11 base image, which provides the Java 11 runtime. The work directory sets the working directory inside the container to GTS time zone services, and the environment command defines a port environment variable with the value 4703, which is the port the application will use, and the expose command indicates the ports 4703 should be accessible from the outside the container. The copy command copies the compiled java.jar file GTS time zone services 0.01 snapshot jar from the target directory and the host machine into the container working directory. Finally, the command instructions specify the command to run the Java application, that is java-jar and a snapshots for jar when the container starts. So these setup ensure the Java application runs inside the container presenting a port number 4703. So this is the Docker file I have written. Start with the implementation part. Go to terminal, take the new terminal. So here I'm taking the WSL access. So now we need to give the AWS configure, because so this command is used to set up AWS command line interface credentials and default configuration settings for interacting with the AWS services, and it promote us to enter a few key configuration. Let's see what are the key configuration they took now. So yes, it's asking for access key. We need to secret key for this. So access key, and then it's asking for secret key. So the access key for our AWS IAM user, and the secret key associate with our IAM user, and the default region, the region where your command will be executed, where the command should be executed, that our Terraform script will executed, that region we need to provide and keep it as default. And next, it's asking for default output format. The format for AWS CLI respond options JSON table or text. I'll keep it as default. So now we need to provide Terraform script commands. So let's go and give Terraform script to execute this file. To execute this file to create for RDS and a EC2 instance in AWS. So I'm giving Terraform init. So this command is the first command you run when you set up a new Terraform project. It initializes the working directories, download necessary plugins, and prepares the Terraform for execution. See, it's showing initialize the backend and initialize the provider plugins. So as the Terraform has been successfully initialized. Now we need to give a command Terraform plan. So this command is used to preview the changes Terraform will make your infrastructure before applying them. It helps you to understand what will be created, modified or destroyed. So it will plan all the things firstly. So we need to wait for a few minutes. Few minutes. It's take time to initialize planning the script. So yes, the plan has been complete. So the next thing, I'm using the command is Terraform apply. So what this command do? So this command is used to create, update or delete infrastructure based on your Terraform configuration files. It applies the execution plan generated by Terraform plan. So click on this. So these Terraform apply will create a resource for us in a AWS account. So once it's started, I'll show you. Still, it's not started to apply. So let's wait few minutes. The first thing we need to check with the security group. Open with EC2 and RDS database. We need to check with the security groups. See, the GTS API is created, and we need to check whether the instance. See, the instance is also created and it's running. So we need to check whether the RDS. Database. See, the database is still in creating state, so it will available in few minutes. So as the security group has been created, and the Ubuntu instance also been created, and the database that we have specified, that's also created. The apply completed, and in the output they have provided us IP address of the instance and the endpoint URL of our RDS database. So let's go and check and confirm once again whether all the resources are created in an AWS account, and let's get further implementation. So as the database is available, and also we have the endpoint URL. This is the endpoint URL, and we need to check whether the security groups. Yes, security groups has been created, and next we have to check whether the EC2 instance. See, the EC2 instance also created, whether the instance type 33 medium, and the status will check. So this is the script we have written in the Terraform for creating security group, CC2 instance, and the RDS. The three of them have been created. So let's move with the further implementation. So these endpoint URL, copy this endpoint URL. These endpoint URL is need to be provided in our code, that is in application.property in our microservices. After change this endpoint URL, we need to create a MySQL workbench database. So let's go and create a MySQL database there. Let's start with the creating MySQL workbench. So here click on plus icon. So here we need to give the connection name. So I am providing AWS GTS. So in the host part, we need to provide the endpoint URL. I have provided the endpoint URL, and we need to provide the username. So we need to provide the password. Click on OK. Click on test connection. So see, successfully made the MySQL connection. It has been created. So click on OK. So see, the connection has been established. Go enter to this. So here in inside this, we need to create a table. Now here we need to create a table. So click on run button. So showing. So we need to use the use, we need to give this name. uh, there is no copy name. GTS service platform DB dev. So now click on run. So see, the table is created. I have created the time zone database. Now I am creating the user token database. So run this. Yes, it has been created. So the next table I am creating is GTS OTPs. Permission table have I'm creating, and the next thing GTS role permission I'm creating. Sorry, this is the role permission I have created. So the next I'm creating the, so wait, am I getting, yes, have, I'm getting error because I have created the role permission directly. So I need to create the permissions first, roles first. Then I need to create the role permission. So as the role table is created, now I need to create the role permission table. That's it, created. So next I'm creating the user. It's creates. So next user personal details I'm creating. Okay. So next I'm creating the user role. Now I'm creating the user tokens. So the user token already exists. So in the left side corner you can see the refresh button. So click on refresh button. So whatever the table is created, it will show here. So as all the table has been created. This is how in Workbench we need to create a tables. So in the EC2, while creating the EC2 instance in a Terraform script, we provide something in a user data to installed in the root user. So we have already set up the Jenkins environment. So copy the public IP address. So paste it followed by 8080. So it will open Jenkins for us. So this part will did in the script only. So that's why we directly opening this. So connect this, copy the path. We need to provide the administrator password. So take the root access. So cat. So this is the password. So click on install suggested plugins. So it will create the package and dependencies, whatever they have, it will install the things for us. So it will take few minutes. So let's wait until it's get done. So we need to provide the name or password. So see, this is the URL of the Jenkins. You can see here also 16.16.201.53. So save and finish. So now Jenkins is ready for us. So click on start using Jenkins. So now we need to set up the Maven path. Before that, we need to install the Maven installation plugins. Go to available plugins. So click on Maven. So this will we need to install. Click on install. So the Maven integration has been installed. So go to manage Jenkins. Now we need to set up the path. So go to tools, scroll down. So in the Maven installation part, we need to give the name. So see the it's required is asking. So uncheck this. So we need to give your name Maven home. So here we need to provide a path. So for go here and give Maven hyphen version. So see the Maven home path. Copy this user share Maven. This is the path that where the Maven has been installed. So see now the error has gone. So apply and save this. So after the plugin installed and we have set up the Maven environment, now we need to provide the credential. So click here. So go to the global. So here we need to add the credential. So in the credential part, we need to give the Git and Docker credential. For a few minutes, I'll pause the video and I'll come back with the Git and Docker up credential. I have added the credential of GitHub and a Docker Hub. I'll show you how to add the credential. So click on add credentials. So in the username, you need to provide the GitHub and the Docker Hub username. In the password, you need to provide the GitHub personal token and the Docker personal token. In the ID, you need to provide the GitHub and a Docker Hub and click on create. So this will create the credential for us. So go to manage engines and now click on create new item. So here we need to provide the name of the project and click on pipeline and click on OK. So if you want to provide description, you can go with the description. And in the trigger part, I am giving the GitHub hook trigger from GITSM polling. So in the pipeline scripting, we need to provide the pipeline script that I have explained earlier. We need to provide the script and click on apply and save. So after this, we need to click on build now. Click only once. The build has been scheduled. So see, it is running. So let's wait few minutes. So see, it has been successfully deployed and the things. See, Maven packages has been deployed and the it has been built and pushed to the Docker hub and finish success. So you can go and check whether the GTS time zone it has been created 3 minutes ago, and you can also see the latest tag that have been mentioned in the pipeline. It's also created. Again, you can see whether the tags also. So go to EC2 instance and check whether the Docker images. So see, the Docker image has been created 3 minutes ago, and you can check whether the container is running or not. Yes, our container is running. 3 minutes ago, it has been created. So so let's go to the Postman and let's check with the APIs whether it's correct, running correctly or not. So before moving to the Postman, I'm starting the server of the identity service. So for that, we need to give the command. So this will start the server of the identity service, that is the port number 4728 will start. Why means we need to add the user and we need to take the token from them. So I'm starting this server. So as we can see, this start completed, it has been started. Yeah, you can see it started, and the Tomcat started on the port number 4728 with the content path. So now let's move to the postman, and I'll show you how to do this. Please note this port number 4728. So this identity service of the server now just have started. So go to the add user. So in this we need to give the path here. So check this. So local host 4728, and the authorization should be in the no auth. So in the body we have this and all. So click on send. So user email already exists. Okay, so let's check it's working correctly. So we need to change the user. So as it has been registered, the user has been registered successfully. So now let's go to the login. So in the login part also, we need to give the same localhost 4728, and the authorization should be in the no auth. So in the body part, so check with the user and send the request. So this will give the token for us. So see, it has been successfully created and have given a token. Copy this token, and these token should be pasted in your microservice. So go to here and go to authorization. So in the value part, you need to paste the token and save this. So what now? The identity service 4728 port number is working well, and we have add the user and log into that user, and we can get the token we have pasted to our microservices. So let's go to the GitHub. I'll explain you something for the automation purpose. Yeah. So just we have send the request and add the user to the table. So let's check whether the data is kept in the data table or not. Go to GTS user, click on this and select the rows. So here we can see the result. So see the user one. So when we give the user to email ID, it tell that the email already exists. So that's why we have given the user one. So see the password and everything will be stored in the database. We have sent the request to the API, and the result, those things will be replicated here in the table. Now let's move. So this is the microservices I have. So till now, what we see is, so go to the settings. So here till now what we do, we just created the pipeline and just we go and click on build now. So I need to that do in a automatic purpose. So when I change any code in the GitHub, it's automatically triggered to the Jenkins. It automatically start to building. So for that, what I am going to do now is, so go to the webhooks. So here we need to add a webhook. Already I have the webhook. So I'll show you how to do that. Go to add webhook. So in the payload part, we need to provide our Jenkins URL. give the Jenkins URL, GitHub web. Okay. So this is the thing you need to give. So rest of the thing will be same and click on add webhook. I'm not creating here. So I have just shown you how to create the things. So here I have just edit this part because I need to change the IP address of this. So I have changed the IP address and I'm updating the webhook. So now what I'm doing is so let's go to the Docker file. So I'll just update a few things here for whether the things will check correctly working or not. For that purpose, I just edit some things. So commit changes. So click on commit changes. So let's go to the Jenkins. So let's see whether the builds started or not. So see, now I'm not did anything. So before what I'm doing, I'm just save the things and build, start to build. Now I set the webhooks that automatically trigger to the Jenkins, and now it started build for themselves. So let's wait. Okay, we are facing issue. So let's check what the issue we are facing. So yes, they're telling that the container is able to reuse the same name. Okay, we need to change the part. So for that, what I'm doing, go to configure. We need to update the things. We need to update the pipeline script here. So yes, I have updated the pipeline script. So what the script I have updated means, so stop the container and remove that container and run that container again. So that is the script I have written in the updated one. So click on apply and save changes and go here and again do any changes and remove this commit changes. So click on commit changes. So you can go to the Jenkins and you can start. So see, I have changed that one and it's started. So yes, it has been successfully completed. So we can see these stages, the things will deploy. So you can go and check. You can check with the Docker also. So see, so before we run with the latest, and the next thing will be tag 3. Why it's showing tag 3 means, so here with the run of the first thing it's showing the latest, so the second has been failed, so now it's showing the 3. So this is the thing, and it has been running successfully, so you can go and check whether the commands docker image. See, tag 3, and about a minute it is created, and you can check whether the docker ps. See, about a minute, 1 minute back it has been created. Let's get the IP address of the instance and check with the API whether it's well working correctly with the cloud or not. So let's go to the cloud and deploy the IP addresses in the Postman. So now, here in this the time zone service, we have updated the token. So let's go and create the time zone by IP address. So here what we need to give is we need to provide the HTTP colon forward slash the IP address colon followed by 4703. That is the IP address of our port number of our microservices. So click on send. So let's check whether it will work or not. Yes, the time zone added successfully. That means it will working locally, and also it will working cloud deployment also. So let's go and check in the MySQL workbench whether the thing will created in the database or not. So now we have created with the time zone, right? So click on select this. So we can see that the time zone GST America and the IST Delhi has been created. So the thing will stored in the database, that what the API we send in the IP address that will store in the database. So this is how the things will work with the APIs and the postmans. So this is the things will work, and this is the automation purpose. I'll completely did this in the automation part. So now we need to destroy all the created items. So let's go to the VS Code, and just by one command we can delete all the resources. So now we need to delete all the resources by this command terraform delete, sorry, destroy. So this command is used to delete all the resources managed by Terraform. It removes infrastructure created using the Terraform apply. By using the Terraform apply, what the resources we have created, by this the command Terraform destroy, all the resources will be deleted. So click on delete. So this will take some time. So let's wait few minutes. So see, it's in a refreshing state. It's refreshing all the things, that is security groups, that the database, and the EC2 instance. So it will take some times to delete all the resources. So let's wait. So I think it's times. Again, we need to give the command, because in enter a value we need to give a yes, because here it shows that destroy cancel. That's why I have given the command again. So see, with the help of the terraform destroy command, see it is in a deleting state. And you can also check whether the here the system will off. You can also check whether the instance, it's in a terminate. The Ubuntu instance has been terminated. Still, the database is in a deleting state. So this is also deleted, and we can go and check with the subnet groups also. So security groups. So the security group still it has been there, because first it should be RDA should be deleted. After that, the security groups will delete. So we can see that our Ubuntu instance has been restrictions completely after 1 minute, and we can also see the database is also deleted, and the security group also deleted. Everything, whatever we have created in the Terraform script, has everything will be deleted by one command, that is a Terraform destroy. So this is how the things will work for securing Microsoft deployment in AWS infrastructure for the automation purpose. So that's all. Thank you.